Okay, in this video, I undid what I was starting to do in the previous one because I want to do it specifically in this one here. And so what I was working on or starting to change was the the point at which let me find this. So in our handle connection, we pass in an owned copy of handlers and an owned copy of stream. And this is too much. The handle collect connection doesn't need an owned copy of stream, and it's actually hurts us because if we're going to have this sort of error boundary, and if we want to return I think it's a 501 indicating that there's some sort of error, we can't do that because handle connection has eaten the stream. It owns the stream, so we've transferred ownership. We don't have access to the stream here to generate an error message back to the user. Now we could wrap handle connection here with something else that is going to catch the error and report it to the user. But even still, this is too much access, too much of types, too much. It knows too much about these types. It's not generic enough. What do I mean by that? So let me just start to sort of fix this, and we'll go back. So the issue is that we really want to say in this error case, we want to write something this sort of thing, but we cannot. Is that a real response? That's not a real response, but this is what we want to do. And we can't because it's going to say we don't own stream. It's also going to complain about other stuff, but there we go. Okay, if I fix this, it'll complain that we don't own stream. Let's just actually, can we do this? That might work. Yes. So it says we cannot borrow stream as mutable because, well, for two reasons. It said that it's not declared as mutable, but then it's going to complain that we don't actually own this here because it doesn't implement copy. This is a bad error message or a bad suggestion. It's not because it doesn't implement copy. The issue is because you transferred ownership to handle connection here, and we no longer have ownership to it. And implementing copy is just the wrong thing to do. So to fix this, we're going to really pass an immutable reference to stream. And now this has a mutable reference to stream. It's not mute there. And we can do this work there. That fixed that sort of thing. Because now, in the error case, we can return in this case, a 500 error code if something bad actually did happen. Now, we can't test this yet. So to test this, I want to here in the handler. So our handler, if you recall, I'm going to sneeze. Hit pause just in the right at the right time. Our handler doesn't have the ability to error. The type for our handler is going to return a response. We don't actually want to return a response. We want to return an anyhow result of a response. So now our handler can error. Now we certainly need to now fix everywhere that we return a value, our handler here, and you can certainly argue that, oh, we should use a different type of a result, or we should type def that. Absolutely should. But this is how we're going to do it here. So in this case, our handler here can return an error. And using our magic question mark operator, we can just propagate that up as needed. I think. Yeah. And then this is going to get propagated too. And this now, expected an enum response. Hold on, let me check this. So this is now returning that. Match arms have incompatible types. Sorry. So we're returning back up. Oh. Let's actually do it all here. There. So our response type here. So like all of this little handler deconstruction gets dumped into this response, and we can deconstruct and report there. Almost done. Test builder pattern. This just needs to return okay. And we have one more here. This is certainly a breaking change, and important to, oh, it's not okay. It's important to get these breaking changes fixed early on. There we go. That should be, man, there's so many here. In part because we have all these tests. Not all of these, there's like 3 of them. It's a somewhat painful breaking change because it hits our user space code very cleanly. But now we're fixed. We refactored to add the ability for our handlers to return some sort of error. And if you recall, let's search for 500. This is now where we're trying to handle the connection, and our error boundary is going to log the error, and it's also going to print a 500 message back to the client. Sort of ironic that we're unwrapping here. Let's not do this. I'm going to do this. I'm going to explicitly drop the error because this is really the last ditch effort. Something bad happened. We could try to write it and log another error, but this is actually maybe the right thing to do, arguably. So let's write some tests, and I'm probably going to refactor my test. So let's do, no, I'm not going to refactor the test because that's going to be more complex. Let's just create a handler that can error. So this is going to be an error handler here. And is client error. I wonder what 500 is. But let's just do that. So, yeah. So that will be a endpoint that will error. And what we want to do is now call this in our request, and this assert will hit because it's not a success. But it's really, let's see if it says that it's a client error. I don't think it will according to the client error. How do we get the status code? Let me pause this and see how we get the status code. Okay, so the status code is server error. So the definition of this status is you have success that falls in the 200 range, redirection 300 range, 400, and so on. And we could actually check what the real status code is here because they're all defined. But this is a good sort of test to make sure that we were able to do what we wanted to do and make sure that if we error in the handler itself, we end up with these 500 error codes. Now, is 501 the right one? Not implemented? That's probably not right. Maybe service is unavailable. There's a better error code to propagate up to the user, but we're at least in a better state to be able to report this to the user and deal with our error handling in this thing. Now, I wanted to talk about the handle connection. We fixed this in the sense that we're not giving up ownership of the stream. We're just giving a mutable reference, which means we have the ability to write to the stream here. Before we transferred ownership, and then we didn't have access to write here, and we needed to fix that. Now, handlers is also to it knows too much about the type of this. Not that it knows too much, but it doesn't need to know this to do its work. What this really needs is a reference to a hash map of this stuff. And we get an error, and it says, hey, you probably should want to borrow there. And that is what we want to do, and it fixes it. So what's going on here is this is holding our ARC reference or our reference counted version of this hash map. And we are now we're moving ownership of that inside of this call here. And here we're taking the reference of it so that handle connections only has access to the type that it really cares about, and only a reference to that, a read-only reference. So then if we needed to somehow wrap this into different types of other things, maybe we don't need an ARC. Maybe we can just use an RC. This allows us to have the handlers or handle connection not have to worry about what type it is. This is actually not passing ARCs, not passing ref cells unless you actually need the ref cell, which rarely you do, almost never you do, is the right thing to do. And I think I want one more. So parse request is taking a TCP stream. And we don't need a full TCP stream to parse. We really just need, let me see if this will work. We need a mutable reference to, so BuffReader, we can actually look at this here. BuffReader needs a R, where R is, let's go look at what our constraints are for R. I believe R is going to be reader. So I think this just needs a mutable impl of, maybe it's just read. Okay. So now parse request will be able to parse anything that implements read, not just a TCP stream. Really good, because now we can test parse request without generating a full TCP stream. This is not generic. Actually, this is very important. If you listen to anything, well, listen to everything. We don't make this generic because we want commonality so that we can reuse stuff or replace stuff. We're doing generics, well, in this case, so we can test it, but also to sort of advertise this is the only sort of thing that we're doing. It's not a good explanation, but we're getting there. So now let's go into parse request, and our handle connection now doesn't need a mutable TCP stream. It needs a mutable read, impl read. I think it also needs write plus write. Sorry, I think we need no reference for shutdown. The shutdown was not necessary. And use parentheses to disambiguate this. At this point, actually, I want to do this. I want to turn this into an actual S. Anytime I start to add more than one trait bound to this, I change my generic definition of functions into actual sort of templates with the where clause afterwards, where S is read and write. There we go. And I think we're probably building and running. Now it says unused imports because we don't need to know about TCP stream, and we've gotten rid of kind of yet another dependency. So now our handle connection is much better. We're just taking a hash map of something. We could turn this into something even more generic as well. I'll get into that later. But now our stream, we can handle anything that implements read and write. And will this work? No. I was going to do something. I'm going to put this aside right now. Because we're hitting almost the 20-minute mark. The sort of next things to do is to start now doing testing, because we're now generic and we don't need to start giving this real TCP streams to work with. We can generate tests outside of the actual construction of TCP. And we can change this to make sure that we're getting what we really expect to get out of the server. Probably not here, but definitely for parse request, because now we can construct a string, tell it to parse a string, and see if we get the result that we expect to get. So let's close out this refactoring, and the next video we're going to go into being able to test some of these internals.